Hello everyone, welcome to Data Structures class. In this unit, we will introduce recursion. In order to use a function or a method in Java, you need to call the function and pass the essential parameters through the call to the function call. As you already know that in a function, you can add statements in the code block to define the procedure of the function. Think about the following special case. What will happen if you call the function itself in the code block? The function may never stop, right? This is known as recursion. Recursion is similar to the situation that you try to stand between two mirrors face to each other. You will see infinite number of you in the mirror. The formal definition of recursion is that a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. This strategy is also known as divide and conquer method. That you split a big project into a set of similar smaller projects and try to develop a solution for the smaller projects and combine the results to obtain the solution for the big project. The power of recursion evidently lies in the possibility of defining an infinite set of objects by a finite statement. In the same manner, an infinite number of computations can be described by a finite recursive program, even if this program contains no explicit repetitions. Most computer programming languages support recursion by allowing a function, also known as method in Java, to call itself from within its own code. Simply speaking, you can consider recursion as a function called itself. This animation demonstrates a recursive function call. As you can see, the program starts from the main method. When reach the blue dot line, we call method A and start to run statements in the method A. As you can observe that in method A, the blue dot line represents a function call which calls itself, and thus we call method A again. This will result in an infinite function call similar to the infinite loop. Therefore, we must properly design the function in order to stop calling itself. Assume that our function is properly designed and stop calling itself in the third call as illustrated as the red dot line. When reaching the last statement in the function returns. As you have learned, when a function returns, it will return to the caller. Therefore, the third method A will return to the caller in the second method A, and then complete the remaining statements of the second method A. Similarly, the second method A will return to the caller in the first method A, and then complete the remaining statements of the first method A. Last, the first method A will return to the caller in the main method and then complete the remaining statements in the main method. As we aforementioned, if a function is not properly designed to stop calling itself, the function will create an infinite number of calls. In fact, each function call will occupy a memory space on your device by using a data structure named stack. A stack is typically created with a limited amount of memory space. For this reason, the infinite recursion will result in stack overflow error at runtime, which means memory space reserved for stack is completely out and the program is still attempting to add an object into the stack. Two common problems lead to infinite recursion include: first, arguments do not get simpler, and second, special terminating case is missing. For example, assume we want to create a recursive function to calculate the sum of 5, 4, 3, 2, 1, and 0 by reducing the number in each function call. That is, we pass 5 to the function in the first call, and we pass 4 to the function in the second call, and pass 3 to the function in the third call, and we continue to repeat this until we pass the 0 in the last function call. In the function call, we should detect that we have reached the terminating case 0 and should stop calling the function. In the above example, if we forgot to reduce the number to the next function call, the argument is never decremented and thus never reaches the stopping condition 0. This type of problem is referred to arguments do not get simpler. Assume we forget to add a condition to detect when the arguments become 0, that is, the terminating case, and thus the function will never stop. This type of problem is referred to the special terminating case is missing. This is similar when you are using a loop. For example, you may suffer from the infinite loop if you forget to increment or decrement the loop variable, or the loop condition is not correctly set. Now, let's see what recursion can do. One of the applications for recursion is that a recursive function can be used to detect palindrome. A palindrome is a string that is equal to itself when you reverse all characters. When testing for a palindrome, only upper and lower cases are matched. All spaces and punctuation marks are ignored. For example, Madam, I'm Adam is a palindrome. As you can see, the first and the last letter are both M. The second letter from the left and the second letter from the right are both A. Similarly, the third letter from the left and the third letter from the right are both D. Because this example has odd number of characters, and thus the middle letter I is not matched with other letter, this string is called palindrome. Another two examples of palindrome are shown on the screen. So how do you design a recursive function to detect palindrome? The first step is preprocessing. As aforementioned, that we ignore all white spaces and punctuation marks and ignore upper and lower cases. For this reason, we preprocess our string by removing all white spaces and punctuation marks and change all letters to uppercase. The second step is that we divide a big question into small parts, that is, divide and conquer. So the first step is test whether a string is a palindrome by comparing the first and the last characters only. Second, test whether the remaining of the string is a palindrome. Here, we use Madam, I'm Alan as an example. In the preprocessing step, we remove all white space and punctuation marks and change all character to uppercase. As you can see in the step 1, the Madam, I'm Alan is changed to preprocess and produce MADAM, I am ADAM. In the second step, our idea is that we design a recursive function to, first, compare the first and the last characters as shown in red as a small part. Second, pass the remaining string as shown in blue to the recursive function for another round of checking. As you can see that the argument is getting simpler. Third, add a proper terminating case in the recursive function to stop calling. A programming homework is assigned to you to create a recursive function to detect palindrome. Please see homework instructions for details. Question?